Have you ever looked at an organic compound and wondered, how do scientists come up with these long and complicated names? What if I told you that in the next few minutes you will learn a simple method that allows you to correctly name almost any organic compound, even if you've never seen it before? Whether you are preparing for JAMB, WAEC, A-level, or Post-UTME, this lesson could earn you easy marks in your exam. Welcome back to Organotope Chem Clinic. If you are new here, on this channel we simplify chemistry so that difficult topics become easy. Before we start, click the like button, subscribe, and turn on the notification bell so that you don't miss any of our chemistry lessons. Now, what does IUPAC mean? IUPAC stands for International Union of Pure and Applied Chemistry. IUPAC Nomenclature is the systematic way of naming organic compounds instead of using the common names. Whenever you are asked to name an organic compound, we are expected to follow this pattern. We identify the longest continuous chain, what functional group is present in the compound, and also we are expected to number the carbon atom in the chain. Then we identify the substituent group that is on the carbon atom, and we have the final IUPAC nomenclature. Make sense? Let's see how it works. Right here we have the mnemonics for the prefixes of the first 10 members in the homologous series. We have monkey eats plenty banana, picking heavy heaps of nuts daily. So when naming our organic compound, we are going to use the following prefix name to indicate the number of carbon atoms in the longest chain. So when we have one carbon atom, it is called met, 2 carbons et, 3 carbons prop, 4 carbons boot, 5 carbons pent, 6 carbons x, 7 carbons et, 8 carbons oct, 9 carbons non, 10 carbons dec. Make sense? Alright, this compound is a member of which class of organic compound? No double bond, no triple bond, just a single bond. That's right, it is an alkane. So we have it as what? Alkane. Recall that I explained in my previous video lesson that when naming an organic compound, you have to follow this pattern of naming. We have the prefix, the parent name, and the suffix. The prefix indicates the substituent attached group on the carbon skeleton, while the parent name is the longest continuous carbon chain, and the suffix is the functional group of the organic compound. Now let's adopt this pattern in naming this alkane molecule. Can we identify the number of carbon in the longest continuous chain? We have 1, 2 carbons in the longest continuous carbon chain. So when we have 2 carbon atoms, it is called what? Et. Okay, so we have this as et. Since we can observe a single bond all through the molecule, it belongs to what? The alkane family, right? So it has the suffix "ane". So in this structure, do we have a substituent attached group? No. Therefore, we do not have any substituents in this molecule. Okay, can we consider the next step, which is numbering the carbon atom in the longest continuous chain? So we are going to consider the forward and the backward numbering of the carbon atom. So we have 1, 2, so 1, 2. Since there is no substituent attached group, so we can combine the parent name with the suffix name. So what do we have? That's right, we have ethane molecule right here. So the IUPAC name is ethane. Now can we consider the next molecule right here? How many carbon atoms are there in the longest continuous chain? That's right, we have 3 carbon atoms, 1, 2, 3. Okay, then we have to consider the functional group in the molecule. Now can we check the functional group in this molecule? We have a double bond, which indicates that this compound is a member of alkene homologous series. So we have the alkene. Okay, now can we number the carbon atom in the longest chain? We have the forward numbering 1, 2, 3, and we have the backward numbering 1, 2, 3. Okay, so let's follow this pattern. Prefix, parent name, suffix. What is the parent name of this molecule? That's right, we have a prop. We can see a double bond in this molecule, so it is what? Alkene. So we have ENE. Okay, let us consider the numbering so that we can know the position of the functional group. Note that we are expected to assign the least numbering to the functional group. So are we going to consider the forward numbering or the backward numbering? So if we consider the forward numbering, we are going to have the double bond on carbon 1. But if we consider the backward numbering, we are going to have the double bond on carbon 2. So which one is right? Yes, having the double bond on carbon 1. So we are going to have prop 1 in. But it is commonly written as propene. Okay? Why do we have it as propene? Since we do not have a positional isomer for this compound, if we move the double bond to carbon 2 right here, I will consider the backward numbering. So the double bond will be seen on carbon 1. We are still going to have prop 1 in. So it is commonly written as propene. Make sense? On our CYK1, check your knowledge. Here is another compound. I would like you to pause the video while you attempt to name this compound. Alright, can we attempt the naming of this compound together? How many carbons are there in the longest continuous carbon chain of this organic molecule? That's right, we have 4 carbon atoms. So let us number in the forward direction, and we have the backward numbering as well. Okay, if we consider the forward numbering, the double bond, which is the functional group, is on carbon 2. Also, when we consider the backward numbering, the double bond is found on carbon 2. So we can start from either side. So we can use the forward numbering or the backward numbering for this molecule, since we have double bond on carbon 2 in both cases. Okay, so how many carbons do we have in the longest chain? Since we have 4 carbons in the longest continuous chain, the prefix name for 4 carbon atoms is boots. Okay, so we are going to have parent name as what? Boots. Then the double bond right here indicates that it belongs to which series? The alkene series. That's right. So we are going to have in as the suffix name. Okay, so what is the position of the double bond in this molecule? That's on carbon 2, right? So we are going to have 2 in. Therefore, the IUPAC nomenclature of this molecule is but 2 in. Make sense? Can we consider this compound? How many carbon atoms are there in the longest chain? We have 1, 2, 3. 3 carbon atoms. For 3 carbon atoms, the longest continuous chain will be given what prefix name? That's right, it will be given the name prop. Okay, we have prop. Alright, next step to take is to identify the functional group in this compound. We can see a triple bond in this molecule. So it is a member of which class of organic compound? That's right, it is alkyne. We have alkyne. Since it is a member of the alkyne homologous series, the suffix name is -ine. Okay, so I'm going to bring -ine right here. Then what is the position of the functional group? So we are going to consider the forward numbering and the backward numbering. We have 1, 2, 3, and also we can number this 1, 2, 3. We are first to consider the least numbering for the functional group, which is the triple bond right here. So if we consider the forward numbering, it shows that the triple bond is on carbon 1. And when we consider the backward numbering, it shows that the triple bond is on carbon 2. So which one is right? Having the triple bond on carbon 1. So I'm going to have 1-ine. Okay, so the IUPAC name right here is prop 1-ine. But note that prop 1-ine is often written as propyne. Okay, so this is the correct name for the molecule right here. Moving on, we have another example right here. We have to name this organic compound. In this organic compound, there are 4 carbon atoms. So what prefix name is given to a compound with 4 carbon atoms? We have the boots. So the parent name is boots. Okay, now we are expected to identify the functional group in this compound. We can see a triple bond in this organic compound. Therefore, this compound is a member of the alkyne homologous series. We are going to give it the suffix name -ine. We have -ine. Okay, now can we number the carbon atom in the longest continuous chain? So we are going to consider the forward and the backward numbering. We have 1, 2, 3, 4. 1, 2, 3, 4. Okay, we are expected to assign the least numbering to the functional group. So if we count in the forward direction, we are going to have the triple bond on carbon 3. But when we count in the backward direction, we are going to have the triple bond on carbon 1. So which one is correct? Forward or backward numbering? That's right, we have the backward numbering right here. So it is found on carbon 1. So we have both 1 ine. Makes sense? We have another organic compound right here. Can we observe the compound closely? It can be seen that we have single bond all through the molecule. Therefore, this compound is a member of which class? The alkane homologous series. So we have the alkane. Okay. Now, can we identify the longest continuous carbon chain? In an organic compound, when you see a terminal alkyl group, it will join the longest continuous carbon chain. So we are going to have our numbering in this order: 1, 2, 3, 4, and this is 5. This is not a substituent group because it is found on the terminal carbon atom. Then we can have 1, 2, 3, 4, 5. Okay, you can see that I did not number this carbon atom, so it is not part of the longest continuous carbon chain. Therefore, it will be treated as a substituent group. The substituent attached group CH3 is known as what? A methyl group. Okay, so a methyl group is one hydrogen less compared to the alkane. Can we consider the correct numbering direction? When we count in the forward direction, the methyl group is found on carbon 2. But when we count in the backward direction, the methyl group is found on carbon 4. So which is correct? That's right. You assign the least numbering to the substituent group. So we are going to have the methyl group on carbon 2. So we have 2 methyl. That's our prefix. So how many carbons are there in the longest continuous carbon chain? That's right. We have 5 carbons. The prefix name for 5 carbon atom is pent. So we are going to have pent right here. Okay, and what will be the suffix name? Since we have single bond all through the compound, it belongs to what? Alkane homologous series. So the suffix name is ane. Okay, so what is the IUPAC name? 2-methyl-pentane. Make sense? Can we consider this compound for our CYK2? Check your knowledge. In this organic compound, we have alkyl group on the carbon chain, and we are expected to consider the substituent group while naming the organic compound. So how many carbon atoms are there in the longest continuous carbon chain? I would like you to pause the video while you attempt to name this compound. Alright, can we name the compound together? It can be observed that many students will identify the longest continuous carbon chain as having what? 4 carbon atoms. No. The longest continuous carbon chain in this compound contains 5 carbons. We are expected to extend the ethyl group right here so as to connect it to the longest continuous carbon chain. In the ethyl group, there are 2 carbon atoms. So we have this CH2, CH3. Okay, here is the ethyl group. So it will connect with the longest continuous carbon chain. Can we number the carbon atoms? We have the forward numbering 1, 2, 3, 4, and 5. Okay. Can we also consider the backward numbering? We have 1, 2, 3, 4, 5. Okay. Let's identify the substituent group in this organic compound. On this organic compound, we have, here is a substituent group, and also this is seen as a substituent attached group. Okay, what is the name given to the substituent group in this compound? CH3 is a methyl group. So can we consider the position of the methyl group? When we consider the forward numbering, we have the methyl group on carbon 2 and carbon 3. When we consider the backward numbering, we have the methyl group on carbon 3 and carbon 4. So we have 3 and 4. Each of these 2 positions will be taken as the lower locants. We have the 2, 3. Okay, we are going to take the forward numbering. That means we have our methyl group on carbon 2 and carbon 3. Okay, then how many carbons are there in the longest continuous chain? We have 5 carbons. So what is the name given to the longest continuous carbon chain with 5 carbons? We have the pent. So what is the parent name of this compound? That is pent. Okay, and we've been able to identify the substituent group in this compound. We have the substituent group on carbon 2 as well as carbon 3. So we have the methyl group on carbon 2 and carbon 3. So the prefix name is 2,3-dimethyl And it can be seen that the compound has single bond all through. So it belongs to which homologous series? We have the alkane. So we have the suffix name "ane". What is the IUPAC name of this compound? That is 2,3-dimethylpentane. Make sense? Here is another organic compound. In this compound, we have multiple functional groups. We have the triple bond as well as the double bond. The triple bond is the alkyne, and the double bond is the alkene. Okay, so in this compound we have multiple functional groups. Since we've identified the functional group, can we number the carbon atom in the forward and backward direction? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so which of these two functional groups has higher priority? So we come to the priority list right here. We can see the alkene and the alkyne right here. The alkene is above the alkyne, therefore alkene has priority over alkyne. So the alkene is the principal functional group. Okay, we assign the list numbering to the alkene right here. Therefore, we are expected to start the counting in the backward direction. Okay, so we have 1, 2, 3, 4, 5. That implies that the alkene is found on carbon 1, while the alkyne is found on carbon 3. Right here, the principal functional group is the alkene. So how do we name this compound? On the longest continuous carbon chain, we have 5 carbons, 1, 2, 3, 4, 5. And 5 carbon atom is what? Pens. So the parent name is pens. Okay, and the functional group right here is ene and the ine. So the ene is found on carbon 1, so we have 1 ene. So we are not expected to put the last e until we have the complete name. Okay, so we still have another functional group right here, which is the alkyne functionality, and it is found on carbon 3. So I have 3 ine. Okay, here is the parent name, and these are the suffix for this compound. And what do we have at the prefix position? Do we have attached group? No. So there is no prefix in this organic compound. So the IUPAC nomenclature for this compound is pens 1 in 3 ine. Make sense? We have another organic compound right here. It is in ring form, and the carbon atom are cyclized. So what prefix name will be given to a cyclic compound? It is cyclo. And this particular organic compound is a member of the cycloalkane. So it belongs to which homologous series? The cycloalkane. Okay, how do we name this compound? It is a 5-membered ring. We have 5 carbon atoms in this compound. So the prefix name is cyclo. And when we have 5 carbon atoms in an organic compound, we have the name as what? Pens. So cyclo to indicate that it is in ring form, and the pens indicate the number of carbon atoms in the compound. So I have cyclo pens, right? We can observe that the bonds in this compound are single bonds, so it belongs to what? The alkane. Okay, so we have the cyclopentane. So cyclopentane is a 5-membered ring cycloalkane. So what is a 4-membered ring cycloalkane called? That's right, it is a cyclobutane. And when it is 3-membered, it is cyclopropane. And 8-membered, it will be what? Cyclooctane. So we have to count the number of carbon atoms in the cyclic compound. Make sense? Here is another compound. We can observe that some of the hydrogen atom on the carbon chain has been replaced with halogen. We have the chlorine right here. We have the bromine on this side. Okay, so what kind of organic compound is this? This compound is haloalkane. So we have it as haloalkane. Okay, because we have halogen on the carbon chain. Okay, now how do we name this compound? We have to consider the halogen atoms on the carbon chain. Okay, so the longest continuous carbon chain comprises of 5 carbons, 1, 2, 3, 4, 5. How do we number the compound? We have the forward numbering 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, Now, the concentration of the halogen is found on this side of the molecule. So we consider numbering from this side because we have higher concentration of the halogen atoms right here. So we are going to take the backward numbering. So we still consider this format when naming the compound. We have the parent name, which is 5 carbons. 1, 2, 3, 4, 5, which is what? Pents for the parent name. We have pents. Okay. And since it is single bond all through, I can put the suffix ane, in. Can we consider the attached group? We are considering the backward numbering. Therefore, we have a chlorine atom on carbon 1 as well as carbon 2. Then we have a bromine atom on carbon 3. Note that in IUPAC nomenclature, when we have similar group appearing twice, we use the prefix di. When it appears 3 times, we use tri, and 4 times is what? That's right, tetra. So, but we have 2 of these similar atoms right here, so we use the prefix di. Okay. Another rule to be considered is alphabetical order of arrangement. We name alphabetically. So bromo comes before chloro in alphabetical order, that is B before C. Okay. So how do we name the compound? The bromo is on carbon 3. We have 3 bromo. On carbon 1 and carbon 2, we have the chlorine atom. So we have 1, 2 dichloro. Okay, pentane. So the prefix are bromo and the chloro, and the parent name is pent, and the suffix name is ane. So we have 3 bromo, 1, 2 dichloropentane. Make sense? Alright, can we consider this organic compound and compare it with this other one? Both compounds contain carbonyl group. Okay, the carbon to oxygen double bond is a carbonyl group. Okay, now in this first compound, we can observe that the carbonyl group is between carbon and hydrogen. So when you see a carbonyl group between carbon and hydrogen, it is aldehyde. Okay, and we have aldehyde, and the class name is Alkane. In an instance whereby the carbonyl group is found in between 2 carbon atoms, the class name is alkanone. The common name is ketone. So the class name is what? Alkanone. So when we are considering aldehyde, we have the carbonyl group between carbon and hydrogen, and for the ketone, we have the carbonyl group between carbon atom and another carbon atom. So there is sandwiching of carbonyl group in ketone. There is no sandwiching of carbonyl group in aldehyde. Also in aldehyde, the group ends with hydrogen atom, while in ketone, the group ends with alkyl group. How do we name this compound? Can we ignore the functional group at first? We are going to have propane. Okay, because the number of carbon atoms right here is 3. So we have 3 carbon atoms, which is prop. That's propane. Can we identify the functional group for the aldehyde? It ends with the suffix al. So I'm going to erase this E and put what? Al. So we have propana. Also for the ketone, we have 3 carbons right here. We have the propane. When we ignore the functional group, can we introduce the functional group now? It ends with O-N-E, and we have one, which is what? Propanone. So when naming a propanone, the position 2 of the carbonyl group is not often written. This is because the carbonyl group cannot be taken to the terminal carbon. So because when the functional group is taken to the terminal carbon, it becomes aldehyde, which is what? The alkane. We are going to have it as propana. So we cannot change the position of the functional group. So we cannot have a positional isomer for this propanone. That is why we have the common name propanone, not propan2-one. Now we have another compound right here. We can observe that the carbonyl group is found between the carbon and the hydrogen. Therefore, this compound is what? Alkane. Can we name the compound? How many carbon atoms are there in the longest continuous chain? Now, the carbon atom of the functional group is considered carbon 1. So we start numbering from here. We have 1, 2, 3, 4, 5. So for aldehyde or alkane, the carbonyl group is always found at the terminal carbon. So we don't need to indicate the locants. Okay? So it will still work. For 5 carbon atom, we have pens. What is the IUPAC name? That's right, we have what? Pentanal. Pentanal, not penta1R. Okay, then can we proceed to the next one? We have the alkanone functionality right here because the carbonyl group is found between 2 carbon atoms. Okay, we have sandwiching of the carbonyl group right here. So how do we name the compound? Can we identify the longest continuous carbon chain? We have 1, 2, 3, 4, 5. 5 carbons, which is what? The pens. So when we ignore the functional group, which is the carbonyl group here, we are going to have the name as pentane, right? But by the time we include the functional group, we are going to have the name as what? One. Is that okay? So what is the position of the carbonyl group right here? So let's number the carbon atom, forward and backward numbering. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we assign the lowest locants to our functional group. So we have the functional group for the backward numbering, we have the functional group on carbon 2, while for the forward numbering, we have the functional group on carbon 4. So which one is the lower locant? That's right, we have the carbon 2. So the position of the functional group is 2. We have 2 on. The IUPAC name of this compound is pentan-2-on. Make sense? Here is another organic compound. We have a carbonyl group linked to hydroxyl group. So when you see a carbonyl group linked to an hydroxyl group, the functionality is alkanoic acid. So we have the carboxylic acid, which has the class name alkanoic acid. Okay. How do we name this compound? We are expected to number from the functional group. We have 1, 2, 3. Okay. How many carbons are there in the longest continuous chain? We have 3 carbon atoms. Okay. How do we name this organic compound? If we ignore this functional group, the name is propane, right? So since the class name ends with oic acid, I'm going to remove the E right here and introduce oic, okay, acid. So the IUPAC name of this compound is propanoic acid. Make sense? Can we consider this compound as well? We can observe that we have the carboxylic acid functionality there, which is COOH. Okay. Can we identify the longest continuous carbon chain in this compound? Note that when you have alkyl group on the terminal carbon atom, it will join the longest continuous chain. So we have 1, 2, 3, 4, 5, and 6. We have 6 carbons in the longest continuous chain, not 5 carbons. Okay, the alkyl group right here will join the longest continuous chain. So can we number the carbon atoms in the chain? We have 1, 2, 3, 4, 5, 6. Okay, that's the backward numbering. And I have 1, 2, 3, 4, 5, 6. That's for the forward numbering. We can see that the functional group is on carbon 1 when we consider the backward numbering, while the functional group is on carbon 6 when we consider the forward numbering. So which is correct? That's right, the backward numbering. So we are going to have the functional group right here on carbon 1. Can we identify other attached group in this compound? We have the chlorine atom right here, as well as the methyl group is also a substituent in this compound. So we have the substituent chlorine atom as well as the methyl group. How do we name the compound? We follow the pattern: prefix, parent name, suffix. So what is the parent name for this organic compound? The parent name comprises of what? 6 carbon. So can we check? That is X. So we are going to have hexane, okay, when we ignore the functional group right here. Okay, what is the functional group name for this compound? We have the oic acid. So I'm going to remove the letter E right here and introduce what? Oic acid. Okay, so that is the suffix name. So can we identify the position of the substituents in this compound? We have a substituent group on carbon 4 and another substituent group right here. The substituent group here is a chloro, while the substituent group here is a methyl group. Okay, so the chloro and the methyl, we are expected to arrange alphabetically. So chloro before methyl. Therefore, we have 4 chloro, 4 methyl hexanoic acid. So the IUPAC name of the compound is 4-chloro 4-methyl hexanoic acid. Make sense? All right, can we consider this compound right here for CYK 3? Check your knowledge. I would like you to give the IUPAC nomenclature for this organic compound. Pause the video and write the IUPAC nomenclature in the comments. Trust me, I will personally check as many answers as possible. All right, can we name this compound right here? We have the alkanoic functionality as well as the alkanone functionality in this compound. So we have multiple functional groups. The next thing is to identify the principal functional group. Now, can we check the functional group priority list right here? From the priority list, we have the alkanoic functionality is found above the alkanone functionality. So the alkanoic functionality is considered as the principal functional group, while the alkanone functionality is the subsidiary functional group. So when alkanone is taken as subsidiary functional group, it will take the prefix name oxo. Okay, so the alkanone will be found at the prefix position for this compound. Okay, so we are going to have the alkanone as oxo. Also, we have another substituent group right here, but note that you are expected to expand the ethyl group because it will join the longest continuous carbon chain due to the fact that it is longer than the what? The methyl group. In ethyl group, there are 2 carbon atoms right here, so it will join the longest continuous chain. Eventually, we are going to have this as the attached group. Okay, so can we number the carbon atoms? We have 1, 2, 3, 4, 5, and 6. Okay, there are 2 carbon atoms in the ethyl group. So the name of this compound, when we ignore this functional group, is hexane, right? So the principal functional group is the oic acid. So I'll remove the E right here and introduce what? Oic acid. Okay, so can we identify the position of the substituent group? We have the oxo group right here for the alkanone on carbon 3, and we have the methyl group on carbon 4. So between the oxo and methyl, which one comes first alphabetically? That's right, we have the methyl before the oxo. So the methyl group is on carbon 4, while the oxo group is on carbon 3. So I'm going to have 4 methyl, 3 oxo hexanoic acid. We have the IUPAC name as 4-methyl 3-oxo-hexanoic acid. Make sense? All right, can we identify other functional group in the priority list right here? We have, this is the alkanoic acid functionality. We have the nitrile functional group. We also have the alkana functionality, which is the aldehyde. Okay, we have the alkanone functionality, which is the ketone. Also, we have the alkanol functional group, which has the common name alcohol. Also, we have the alkanamide functionality, also known as the amine. Then we have the alkene functional group. Alkene functional group has priority over the alkyne. Take note of that. Then we have the alo group, then the alkyl group at the bottom right here. So here is the priority list that you need to consider when naming organic compound. In order to identify the principal functional group for the suffix position, we need to follow the priority list for the functional group. So the subsidiary functional group will eventually be found at the prefix position. When we have more than one substituent group, you arrange the substituent attached group alphabetically. Make sense? Alright, can we consider another class of organic compound? The OH group right here shows the compound belongs to which class of organic compound? That's right, the alkanol. So we have alkanol, also known as the alcohol. Now let's identify the longest continuous chain. How many carbon atoms are there in the longest continuous chain? We have 4 carbons, 1, 2, 3, 4. So let us take the forward and backward numbering so as to identify the position of the OH in this compound. We have 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we assign the lower numbering to the functional group. When we consider the backward numbering, we have the OH group on carbon 2. But when we consider the forward numbering, we have the OH group on carbon 3. So which direction are we going to consider? The forward or the backward numbering? That's right. We are going to consider the backward numbering right here. So the OH is found on carbon 2. So I'm going to clean this. So we have OH group on carbon 2. So what will be the IUPAC name of the compound when we ignore the functional group? Since we have 4 carbons is what? But. So we have butane right here. Can we eliminate the E right here? Then we introduce the ol, which is the functional group name. We have ol. Then what is the position of the OH group in this compound? It is found on carbon 2. So I have 2-ol. Then the IUPAC name of this compound is butan-2-ol or 2-butanol. Makes sense? In an instance whereby the OH group is found on carbon 1, that implies that we start counting from this side as well. And the IUPAC nomenclature of the compound will be what? That's right, butan-1-ol, when the OH group is found on carbon 1 right here. Can we consider another class of organic compound? We have NH2 group right here, which shows it belongs to which class? The alkanamine. So we have alkanamine right here, or the amine. Okay. How many carbons are in the longest chain? We have what? 3 carbons, 1, 2, 3, which is what? The probe. Right? When we ignore the functional group right here, it has the name propane, right? Okay, we have the propane. Can we eliminate the E to introduce the functional name, which is the amine? We have the amine right here. So the name becomes propanamine. The compound right here is propanamine, or we can introduce the locant, which is the position of the NH2 group. So it will be called what? Propan-1-amine or 1-propanamine. Make sense? Alright, we have multiple functional groups in this compound. Can we number the carbon atoms? We have 1, 2, 3. That's the forward numbering. And also we can have 1, 2, 3, which is what? The backward numbering. Where is the principal functional group in this compound? That's right, we have OH group above the NH2 right here. So I cannot ask priority over the amine. Since the OH group is the principal functional group right here, we are going to take the backward numbering. That is, the OH group is found on carbon 1, while the NH2 group is found on carbon 3. So we erase this numbering and we take the backward numbering. Okay. So what will be the IUPAC name of the compound? Let's ignore the functional group. We have the propane. Okay. And when we introduce the functional group, we eliminate the E. So on carbon 1, we have the OH group, which is 1-ol. And the substituent attached group right here, which is the subsidiary functional group, is found on carbon 3. And it is called the amino when it is found in substituent position. So we are going to have what? 3-amino, okay, propan-1-ol. So the IUPAC name of this compound is 3-amino-propan-1-ol. Now this comprehension challenge is for you. Give the IUPAC nomenclature of the organic compound right here and drop your answer in the comments below. If this lesson made IUPAC nomenclature easier for you, give this video a thumbs up and share it with a friend preparing for JAMB, WAEC, A-level or Post-UTME. Subscribe to Organotope Chem Clinic and turn on the notification, because in the next lesson we will solve exam standard IUPAC naming questions exactly the way they appear in major examinations. Until the next time, keep learning, keep practicing, and remember, Chemistry becomes simple when you understand the concepts. See you in the next class.